So today's video, we're going to be doing something a little bit more interesting. Today, this is what I consider like real hacking, I guess, but whatever. By that I mean we're actually going to do some cool exploitation stuff. This is supposed to be really easy, but of course I wasn't able to solve it, so I did find a write-up. I'll show that in a second. Today we're going to be doing a binary exploitation. It was actually pretty cool, and kind of amazed how this is like on the easier end. I did kind of try to figure this out on by myself. I did get kind of far, but not really there. So yeah, I did need a write-up. This is my first time actually trying to solve any of these types of problems, so it was nice to have a help. So let me show you what that is. So this is the one we're going to be working with today. It's called Stonks, and the description is I decided to try something no one else has before. I made a bot to automatically trade stonks for me using AI and machine learning. I wouldn't believe you if you told me it's unsecure. So here we have a .c, which is, well, a C file, and a server we can connect to. So I think I might just use the built-in one, unless I'll just start up a VM so we can connect to it. I'll use my Kali instance. So if you guys are following along with me, we are going to need some sort of terminal here, either a Unix based terminal, either something, Linux or Mac. If you don't have any of those options available to you, and you don't want to set up a VM, you could use this Pico terminal here. All you have to do is just log in with your Pico credentials. But yeah, so let me download this. And let me make sure this is good to go. Okay, cool. So let me open up this file. We are going to want to read this code. I'm going to try to... Oh, before I get into that, actually, let me just show you the write-up that I'm going to be using today. This write-up is on Code Dead by Orion. I feel like I'm saying that wrong. Whatever. Sorry for butchering your name, but yeah, it's a pretty good write-up. I'll put this in the link below if you guys want to check it out. I am going to walk through it. I guess starting from here, I'm going to walk through the code with you guys and kind of break it down a little. Okay, so let's do that first. So if you aren't too familiar with C, sorry, I might skip over a few things, but I'm going to try to break down everything I can as much as I can, as fast as I can. Cool. Okay. Also, some things may not be entirely correct. Just laying that out there right now. I'll let you know if I'm not sure of things. So these are some things we're going to need. Honestly, I'm not really sure what a lot of these are used. Well, this one's obviously for strings. So, because we're going to be using, what is it? Like a scanning. This is used for time. I'm guessing for a randomization somewhere. STD library. I think that's for the flush. For the STD out. And STD IO, not really sure what that is. Okay, so these two right here are just two structures to define for stonks and portfolios. Doesn't really pertain to us for right now. This is a view portfolio function. This is a pick symbol with AI function. Okay, by stonks. So far we have 3 functions, 4 well, this is just an initialization of portfolio. Like this just randomizes it, the money. Yeah, that's all that really is. Free portfolio. Okay, this forget the word. Is it destructure? But pretty much I think because here we're allocating resources with the malloc. We're pretty much telling the kernel, we're letting the OS know pretty much we need whatever the size of the portfolio is, that's how much memory we need. And of course, so we won't hold on to those resources even after the process ends. We need to free it up to let the OS know okay, we're done with this, you can have it back. So here's the main. Okay. I thought I wasn't sharing my screen for a second. Okay, so here's the main set buff. So we're setting the buff. We're doing a randomizer for the portfolio. We're initializing it. If not P, what's this? Oh, so if we don't have a portfolio, that means there was an error with the initialization and, you know, getting that allocated memory. So it's going to exit. Doesn't really pertain to us. And here's where it gets juicy. So the first thing is we have two options: buy Stonks and view portfolio. And it looks okay. So after we go through either of those options, then it just lets go of the memory and it exits. So let's check out buy Stonks first. Okay, that's here. Same thing as before. If we don't have a portfolio, then just kind of exit. Okay, so here we have our flag. That's what it looks like. So it looks like the flag is saved within a file onto the server, and they're opening it up there, and I guess just saving it into a variable API buff. I'm guessing that's yeah, that's where it looks. I think that's what they're saving it to. I'm not really familiar with how files work in C, but I think the flag itself, the contents within that file API are saved in here, because that's what the hint was. Okay, maybe I'd believe you if you find my API key, because he wants us to prove that his code is, you know, vulnerable, unsecure. That's the word. Okay, so we know that the flag is saved within a variable onto in the program, so that lets us know it's on the stack, really, and that's important. I'm gonna touch on that later. So we have these. Doesn't really seem important. Doesn't really seem something we can like exactly mess with. But here we see some comments. Figure out how to read token from file. For now, just ask. Okay, so this is where they're getting some input from us. So I see this user input, and I think, okay, we have to do maybe some, again, not really familiar with this type of realm, like, you know, binary exploitation. Just from what I've heard, I was saying like buffer overflow maybe, because here we're allocating, I think these are bytes, 301 bytes. But then I noticed that when he asked for the input, he has this syntax. So I did a little bit of digging in that, and it turns out that yes, this could potentially be, you know, a vulnerability. However, the way this is set up, it kind of cancels that out, as yes, it only takes 301 bytes, but regardless of what the input is, it only takes in 300 bytes, and it interprets it as a string. So I'm like, great, that's not gonna work. So this is kind of pointless for now. So let's look at the other one. What is it? View portfolio, which looks like it runs even after buy portfolio. Okay, same thing here. This is important too. So what this does is pretty much, I don't exactly know how to explain it properly, but it kind of just clears. I'll just look it up because I don't want to say anything that's entirely incorrect. Like, I kind of get it, but so fflush is typically used for output stream only. Purpose is to clear or flush the output buffer. So yeah, pretty much for like, there's a buffer and it clears it, I guess, kind of to prevent a buffer overflow. Like, that's the general purpose of it, right? So also, because this comes after the, what do you call it, the buy portfolio, I'm thinking, okay, yeah, definitely we can do like a buffer overflow thing here. And yeah, it doesn't look like there's anything useful in here too. Kind of just reading through the stonks in our portfolio. So yeah, that doesn't really get us anywhere. Okay, so next thing I'm thinking is, where else can we get user input from? And that's here. I look at it, and there isn't necessarily a set, well, I guess this would be our buffer, but you know, it kind of just takes in whatever it wants. All right, so let's check out the write-up real quick. I don't want to get too far in it. Okay, so the first thing to do is kind of connect to the service and test it out. Let's do that ourselves too. This is my VM that I'm going to be using probably in the future as well. That's great. Okay, let's view the portfolio. Nothing. And then let's buy some stonks. What is your API token? Pizza. And then it just buys random stocks and outputs it using the view portfolio. And the reason why we didn't get anything here is because we don't own any portfolios. Okay, so that's what they do here. Spotting the bug. Tracing execution through the first option, we spot an interesting block within the buy stonks function, which is what I was pertaining to earlier. So notice that the printf on line 93 specifically notice that the supplied format string actual data that we control, the application is supplying it. Okay, so yeah, that's exactly what I was saying. How so yeah, it does prevent like that overflow thing. However, it can still possibly be exploited. So here they pass in what is that called? Percent sign? Yeah, I'm gonna just say percent. So %p. So you're probably thinking, okay, what is that? So I believe that returns the address of the pointer in C. Format specifier. Oh, I guess, okay, so format specifier is used for printing the value of the pointer in C. Well, I guess, yeah, the pointer, okay. So it returns the value of the pointer of itself. So the program dumped out would appear to be a valid pointer. So we know that we can exploit or use this pointer to our advantage, but how? So they end up tinkering it with a little more, and they see, as I mentioned earlier, that the file is being saved into you know, the variable, and we know that it's saved onto the stack. So next they do another test and send in a bunch of parentheses at %s. Let's check that out. A string. Well, obviously. Oops. Display. No, that's character. Okay, so this honestly, I do need to do a little bit more digging in this, if I'm being honest, because I'm not really sure why they used this to try to pull the flag or kind of like understand what output it would get out. Dump chord bump. So our flag's sitting on the stack, you know, because they pull it here and they save it onto a variable. And we know that the printf will pull data from the stack in a sequence to match format specifiers in the supplied format string. Okay. So they supply a bunch of, you know, I could even follow this along. They do that, and then that. And yeah, we get a mess. And, we do get some P's, which could mean Pico. It could be the Pico flag. So that's interesting. And since I'm here, actually, I did want to point out something cool that I didn't really know about C that you can do in, and I actually, you know, looked this up. Actually, ignore that. So yeah, I thought this was pretty cool. So when it does this kind of goes back to the F flush thing. So when it's doing a scan F, it actually takes in kind of like separate inputs. So for example, if you're familiar with the term delimiter, kind of, how else can I? Okay, so a character, okay, so a delimiter is a character that marks the beginning or the end of a unit of data, right? So to my understanding, scanf uses a space, like, you know, an actual space as a delimiter, meaning if I were to put 1, for example, 1 and mess just all together as one, you know, bundled string, I should get an error. Wait, that shouldn't have worked. Well, wait, what? Can you even see this? Well, okay. What I was trying to get at is, but I'm still kind of interested in how that worked. I get it. I get what happened. Okay, let me explain. You guys are probably like, what the hell are you thinking about? Okay, so here we're taking in, what's the decimal digit, one of those. Okay, decimal integer. Cool. So we're getting a decimal integer. So since we're passing in, I can't scroll up because great, I broke it. So since this obviously is a decimal integer and that is not, it considers it as two separate data. So I'm a burp, sorry. So since there isn't a flush like this, the program interprets that one because it is the only decimal integer. It's saved like in a buffer, and it kind of just transfers over into the next input. I think that makes some sense, right? So this one is interpreted or taken in as input for this scanf, which is, you know, the input, and the rest of it, this string from D to S, is the input for this one. So yeah, sorry, probably not my best explanation, but I think you kind of like understand what I'm trying to put together here. Why is that important here? Probably isn't, but I figured this can probably be useful maybe for other challenges in the future. That's like, say for example, these were reversed, right? So I'm not sure if this would work exactly, but say this one had, you know, this kind of 300s that it can't take more than 300 bytes or 300 characters here. But maybe if we typed in 300 characters here and there was another input later, we can kind of like pass in those characters into, yeah, okay, this isn't even part of the challenge, but I just thought I'd point it out. So they noticed that these are also getting input and it kind of just broke it. Yeah, that's their point. So then they're thinking, what if instead we send a sequence of %p specifiers? We should then get it back a sequence of 32-bit hex values. It should be relatively easy to spot a string of ASCII bytes among the other data on the stack. To make things easier, I'll create a file to pipe into Netcat's input stream. So this is what they pass into the program. The underscores are simply to make out the input easier to parse. If we use spaces, scanf will stop reading at the first space. So that's kind of what I was also getting at. Because if you do this, can I not? No, I can't. So if you do this, one, yeah, it kind of just stops reading here and kind of just passes it over, but I guess because that's still on the buffer anyway. So yeah, let's do what they did. Let me copy this. Also, a reason why I pointed this out earlier is so it wouldn't be confusing when I do this, kind of just easier for me and faster. And as you can see, the output we get is a bunch of hex, which to my understanding is just pointers from the stack. Yeah. Okay. Somehow, I don't, if there's a genius out there, I know you're probably going to break apart my entire explanation because I don't really know what is going on here. I'm trying to understand so I can learn, you guys can learn. But I honestly, they said, so we see that what looks like to be ASCII beginning at the 15th spot. If we quickly decode the 4 bytes, accounting for Little Endian is, if you don't know what that is, I'll try to explain that in a little bit. We get the string Pico. We can copy everything from the first block of ASCII bytes until the block containing a null byte and work with little Python magic. So they use Python to interpret the hex that's dumped. I'm going to do something else. But first, let me explain Little Endian is. I'm get a little picture from Google. No, I don't like any of these. Okay. I probably should have had this prepared. I think I might just go with the first picture. Yeah, okay. So, there's in computers, as you know, everything it interprets are binary. It's binary. So 1 and 0s, right? And it stores that just everywhere. That's what it reads, that's what it writes. Binary. That's it. From binary, we can get hex, which is what you see here, like 60. Oh, they have it right here, I think. Is that the? No, that doesn't look right. Because I'm pretty sure. Oh no, actually, yeah, that is 1. Wait, what? Why do they have it like that? Okay, just ignore what I'm saying right now. But it looks like these values in here, like the green and the orange, are hexadecimal values, which are derived from binary. Whew. Okay. So hex obviously is a lot more easier to understand than binary is, so it's used more, to my understanding, kind of when just interpreting code. Not code, I'm sorry, just like data. Like for example, there's this application called HXD, which is pretty much kind of a hex analyzer of data. I've used this for my forensics class. Probably have a challenge in the future using this thing. I'm just trying to. Okay, so as you can see, we can pull in a random file here, and we can read the actual hexadecimal data from here. However, it can be stored in 2 ways: Big Endian and Little Endian. So that's why I don't like this picture. Okay, this is better. If it can. Are you serious? There we go. I hope you guys can see that. Okay, so this is Little Endian and Big Endian. So say we have this string of hex decimals, usually in groups of 2, which I believe are bytes. 1, 2, 3, 4, 5, 6, 7, 8. Yes. No. Oh, what's the word for half of byte? I should know this. Name for half a byte. Oh, I'm so disappointed. Nibble? Alright, nibble. So these are nibbles, meaning 4 bits. Yeah, that makes sense. Okay. And they're grouped by bytes. So this is 1 byte. 0A, 0B is another byte, 0C is another byte. So the way they're stored in just stored is Little Endian stores them. So say this is, okay, so this is the beginning and this is the end. So say you are reading these values either from here to there or here to there. In Little Endian, you read them from here to there. In Big Endian, you read them from here to there. So as you can see, they're stored differently in the memory, because in the memory it starts with 0D, which is the end of, you know, this data here in Little Endian, and in Big Endian it starts at 0A. So all it is just different ways of like storing and reading values, kind of just inverts of each other. I believe in Unix, and maybe in general, this could be wrong, but for the most part, you're gonna see things in Little Indian. Wow, that was a horrible explanation. If you actually want to learn about that, there are much better videos out there, but this is not the point of that video. Now that we have this hex, let me copy that. Let me show you a cool little site that I discovered. Well, I didn't discover it, well, kind of, just from a YouTube video, CyberChef. It's you can do pretty much a lot with it. So as you know, we have hex value. This is, it just dumped, but we need to read it from here to here. Little Indian. If it was Big Indian, then we need to read it here from here. So let me actually pull up this little doc I put together just for my notes. So the first thing we want to do is swap the Indianness, because right now we're reading it in Big Indian. We want to read it in Little Indian. And now that I think about it, do I need to get rid of these? I hope not. Okay, so now we've swapped them. The next thing we need to do is interpret the hex into Ascii. And there you go. We have some text here. So as the write-up was explaining, is we need to kind of just figure out where the Ascii bytes begin, because the rest is kind of just random things from the stack. So honestly, they were able to somehow find where the Ascii starts just by looking at the bytes. I'm not that good at that, so I kind of just started breaking it apart and deleting things. And you see it's broken there, right? So I probably deleted too much or too little. So I kind of kept playing around with it until I got this, right? So if you want, you can clean it up a little bit more. Was that too much? Yeah, that was too much. What about right here? I think I duplicated it, didn't I? No? Okay. Here. This one? I'll just keep it. Doesn't really matter. But as you can see, we have our flag here. Wow, I do realize not going through this, I did a very poor job explaining this. And I'm very sorry if you were hoping to get a full, in-depth, clean explanation. But we're learning here. I know if there's somehow someone out there that's watching this that's very, very good with binary exploitations, I'm gonna get absolutely destroyed. But I'm okay with that. I'll take the criticism, but I hope those that are learning as well did learn a thing or two. I know I definitely did learn while doing this challenge. And I hope you guys, go out there and try it. All you really need is access to Pico. You can get your terminal straight up from here. And just anything to view C in. I mean, you can literally use Notepad. So yeah, I hope you guys enjoyed this video. It was a train wreck. I'm gonna try to do a little better next time with binary exploitation. If I ever do come back to it, I will in the future. But yeah, thank you for watching. Hope you enjoyed. Please subscribe, like, and please watch my future videos. They will be better than this. Thank you.